My name is Wenxin, and I'm going to present the building NLP model with Azure Machine Learning's AutoML NLP capability. So thank you for a quick introduction and instruction of myself. I can also share a little bit of myself. My name is Wenxin, and I'm currently a product manager at Microsoft Azure Machine Learning. And please also see my email if you have any question regarding Azure Machine Learning, or if you are using Azure Machine Learning and having any feature requests, feel free to shoot me an email and we can have a quick conversation. I'm happy to learn about what you think about our product and what you're looking for our product. So before I jump into the, what is AutoML and how AutoML NLP works, I want to first introduce what is Azure Machine Learning and what you can achieve here. So Azure Machine Learning is an end-to-end machine learning platform in Azure, and it allows the data scientists and ML professionals to create and deploy a model. So you can bring your data and do data pre-processing in Azure Machine Learning Studio and bring your data to a training experience. You can create a model with Azure Machine Learning notebooks. You can create a model with AutoML, which does not need you to write any training code to build your model. You can also bring your model from some other open source tools like PyTorch, like TensorFlow, and with the model, you can also build a pipeline that can bridge your data preprocessing, training, and deployment process. So with this training experience, we also provide you with a responsible AI that can help you to understand your model. And if you're having your model ready, you can also leverage the MLOps offering in Azure Machine Learning for a CI/CD process and also a smooth deployment and retraining process. So for today's demo, I will focus on the AutoML section in Azure Machine Learning training experience and show you how you can building an NLP model easily without running any training code. So in this next slide, I want to show you how you can build AutoML. So what is AutoML in Azure Machine Learning? So AutoML, it automates the data featureization, algorithm, and hyperparameter selection in order to find the best model. Normally, the featureization and the algorithm selection part is the most tedious part when you are building a model. And in AutoML, what we are doing is the user, you can just bring your own data set and you set some configuration and constraints like you want to block some algorithms and or you want to set some parameters. You can set those constraints. And once you give us all this configuration, we are going to do the featureization for you. We are also going to select the best algorithms based on the performance metrics you selected. And we are also going to do hyperparameter tuning based on your data set. And we'll, at the end, provide a model leaderboard that shows you what is the best model based on your data set. And you can take this model and use the code generated by this model to see whether you want to continue with the model for deployment or you want to add this model for future use. So how AutoML works right now in Azure Machine Learning and what is the scope? So for AutoML in Azure Machine Learning, it's just originally start from Microsoft research. So it's backboned by a lot of research and experimentation. And we have teams of data scientists who are working hardly to bring this to the customers. And now we have supported a lot of ML tasks. For general tabular data, we support classification, regression, and time series forecasting. All this 3 functionality has already been GA'd. And for the more advanced use cases like NLP and computer vision, we also have this 2 experience in public preview. For AutoML for images, we supported 4 different types of ML tags for image classification, multi-label image classification, object detection, and image segmentation. And we are also working on to include more scenarios here. And what we are going to talk about today is AutoML for NLP, which is also in public preview. So it allows you to bring your own text data set and do text analysis. So now we support 3 different types of ML tags, which includes the text classification multi-label, and text NER, which is name entity recognition for extracting some domain-specific entities. So this is a quick overview of what is Azure Machine Learning and what is AutoML. So based on this background, now we can jump into what is the AutoML NLP. And so for the beginning, I want to introduce AutoML NLP is an end-to-end NLP model training without the need of writing any training code. So as I mentioned before, all the model will be pre-trained by us. So you will be benefit from all the pre-trained model. And we also gonna allow you to do hyperparameter tuning based on your data set. And we are also gonna do fine tuning based on your data set automatically by default. And with AutoML NLP, we also brings the best of the science innovation. So we are leveraging a lot of the most cutting edge innovations from open source tools and also from Microsoft internally. For AutoML NLP, we are leveraging the model from transformers, and we adding a lot of innovation from MSR, and we also leverage some open source tools and domain specific enhancement, and we bring this together to bring a best performing NLP model to you. And in order for you to use AutoML NLP, we also have a very simple interface for the non-advanced user, and also give advanced controls for those who are looking for more control over the model, like they want to set up more configuration and constraints. So now we're supporting Python SDK and also UI for you to submit an AutoML NLP job. And I'm going to show you later in the slides. And we also have this rapid rollout in the enablement of the new NLP tasks and scenarios because we are within the Azure Machine Learning platform. So we, besides the 3 different tasks I just introduced, we also want to bring more NLP tasks like text summarization, sentiment analysis, for all this stuff into Azure Machine Learning. So this is a quick overview, and since the feature is currently still in public preview, this is a quick overview of what we already supported in Azure Machine Learning's AutoML NLP. And from the scenario-wise, we support this 3 scenario, multi-class classification, multi-label, and NER. And from the capability-wise, we actually have a lot of innovations. So we have this an end-to-end automatic DNN training, and we have multilingual support with support of 104 languages. So you can just give us the language of your data set, and we will choose the best base model for you. And sometimes for NLP models, it's going to train longer. So in order for you to accelerate the training process, we also support distributed training for fine-tuning at scale. And I'm going to introduce how we are enabling distributed training and what is the background technology behind it in the later slides. So before we jump into the technologies, I want to give a quick instruction of what are all these tasks looks like if you're not familiar with it. So the first will be multi-class text classification. And in this case, there will be multiple possible classes, and each sample can be classified into exactly 1 class. And our task is just to predict the correct class for each sample. So you can see in this example, each text sample can be correlated to one specific sport. and it cannot be assigned to multiple label, and we are trying to predict the right one. So this is like more of a one-to-one prediction. And in order to have a difference for this, like we also support this multi-label classification. And in this case, there can be multiple possible classes, and each sample can be assigned any number of classes. So there can be no label, there can be one label, there can be multiple label. And our task is to predict all the correct classes for each sample. So you can see in this example here, like you can classify it as only one label or like multiple label, and even like there's no label for this specific text sample. And for the third scenario we are supporting, which is name entity recognition, there can be multiple possible tags for the tokens in sequences. So this task is what we do to extract domain-specific entities from unstructured text dataset. And we are doing this by predicting the tags for all the tokens in each sequences. So for NER, we will require you to convert your dataset to a specific format in order for us to extract this specific tags. And you can see in this example, you can use it to extracting the persons, locations, organizations, or like whatever kind of domain-specific entities from your document. And this is the overview of like what are the tasks we supported right now. And sometimes you are building your own NLP model, and I want to say like what are the value proposition of AutoML NLP, and why should you use AutoML NLP for your text analysis? So we have adding a lot of the scientific innovation for you if you're using AutoML NLP. Like the first one will be like how we are enable distributed training and how we can make sure our performance is better than what is offering in the market. And we have supported large-scale distributed training on multiple GPU clusters, and it also allows you to achieve both scale and accuracy. So to achieve this, we have collaborated with the Microsoft research team to achieve the best training performance for the distributed training job. And we are leveraging Harvard MPI InfiniBand, and also including the Microsoft research latest algorithms to get a high scalability. So this is a really cutting edge distributed training experience. And for you to use it, you don't have to do a lot of the configuration stuff. You just need to have one line of code to enable DNN distributed training. And we are going to automatically doing all these things for you. And this will largely accelerate the training process. And I'm going to show you a benchmarking table in the later slides. And we also support like 104 languages backed by the extensive experiments. So you just provide us with your language, and we are going to select the best base model for you. And what's next? We also have the dynamic selection of max sequence length to boost the performance on longer range text. So if you have your text dataset with over 256 tokens, like we can also handle that for you. And we have the ability to handle multiple text columns. In order for us to help you to reduce the training error, we also going to do a data validation beforehand to reduce the NLP specific data formatting pitfalls. So in the later slides, I'm going to show you like what are the data validation we are doing, and if you're using it, how can you make sure your data is follow the right format. And we also have this great integration with the AML evaluation metrics. So once your NLP model has been trained, you can use the Azure Machine Learning Studio UI to monitor your metrics and analyze your metrics, or even compare your metrics between different runs. And if you are satisfied with your model, you can also leverage all the existing ML components to do the model development and model versioning and model registering. We currently support like batch endpoints and manage endpoints, and you can also leverage the ML ops and ML pipelines capability to build your end-to-end experience with this NLP model. So this is an overview of what are the innovation we added to AutoML NLP, and I'm going to show you more detail about each specific bullet point. So we want to start it with data validation. Before your training started, AutoML will apply data validation checks on the input data to ensure the data can be processed correctly. For you to use AutoML NLP, we will expect you to bring your label data. And we also have this integration with AML's data labeling service to help you label your data. So in that case, you can either bring your label data by yourself, or you can go to Azure Machine Learning and do data labeling in our data labeling service, which is also backed by AutoML NLP for text dataset. And once your data is being labeled, you can bring this in to AutoML NLP and train an NLP model to predict the further labels. And with that, you have to have your data set in the right format. So this is a quick overview of what are the data validation checks we are doing right now. So for all the 3 tasks, we need at least 50 training samples. And for multi-label and multi-class classification, we have to let you to provide us with the training and the validation data set, which must have the same set of columns and also the same data set for each columns with the same name. And this is just a couple of the different checks we are applying for. And one thing to notice is for the multi-label classification, in order for us to distinguish between multi-label and multi-class, at least one sample in this multi-label text dataset, it should have 0 or 2+ labels. Otherwise, you can just use it as a multi-class classification. And for NER, it's a little bit different because for NER, we will require you to bring your data with a special format, which is called :L. It's a very general format that we are using in the industry for the NER tags. And in this case, you will have a couple of different checks for your NER dataset. You have to follow what it looks like for the L format in order for you to pass this data validation check. And all this data validation is to help you to reduce the potential error you will encounter when you're actually doing the training. So data preprocessing is a really important part for you to do either AutoML NLP or if you are doing image classification. So this is the data validation part. And I also want to show you an architecture diagram about how we are building this AutoML NLP experience. So from the customer side, you will need to do this data preparation. You can bring your own data set and preprocess your data to follow the right format. And we are going to do this data validation check for you. And once that data validation check is passed, we are going to start training. So we bring this pre-trained model and tokenizer from transformers. So our base model is from transformer, and we are also expanding the models we supported and adding most cutting edge model and give you the best model you can use for your data set. And for this pre-trained model and tokenizer, it's also determined by the language setting. So as I mentioned, you can provide us with the language of your data set. It can be single language, or it can also be multi-language. So your document can contain a lot of different languages, and you just need to let us know that you have this multilingual data set, and we are going to determine the pre-trained model for you. And once we have this pre-trained model and tokenizer, we are moving to the model fine-tuning. And AutoML will do the fine-tuning for you based on your data set. And also, once we have this fine-tuned, we are going to have this fine-tuned model that can provide it to you for the deployment and evaluating. And from the customer side, like what you need to bring is like you should provide your data set. You should see if you have any configurations or settings you want to set, which is the language. And you have to provide us with a compute you want to run on. So currently in Azure Machine Learning, we are building based on the compute consumed. So it's a little bit different from what is offering in the market. So most of the offerings in the market is depending on the document size. However, for us, we are depending on like how much compute you are consumed in order to train your model. So this is a little bit different. And as I mentioned, like once you have your model trained, like you can go through the deployment process with batch endpoints or managed endpoints. You can also further evaluate your metrics and iterate it on the model with the code gen capability, which will provide you the actual code that generated this model, and your developers or your data scientists can use it for further model iterations. So for the next part, I want to talk about how we are going to achieve distributed training. So we supported distributed training with Harvard, MPI, and InfiniBand to get high scalability. And as I mentioned, we are using MSR's latest algorithm, AutoSM, for the robust training on multiple GPU clusters. So if you look at the graph in the right, so it shows the speed up using the NC24RS V3 compute. And in this compute, each VM has 4 V100 GPUs. And you can see from the right graph, like how this speed up looks like with different number of VMs. And noted that the number is normalized here. So the 100% in the y-axis is the runtime when using one VM. And you can see like there is almost an ideal speed up while maintaining the high scores like accuracies when we are doing distributed training. And this is backed by a lot of the research done by our data scientists. So we will highly recommend you to use a distributed training for your NLP model or for your image model. And now I'm going to switch to a demo and show you how you can use AutoML NLP to train a multi-label text classification using AutoML NLP capabilities. So please bear with me. I'm going to switching my screen. So now you can see this is an example notebook about how you can build a AutoML NLP model for text classification. And this is using the Python SDK in Azure Machine Learning. And I'm going to show you like how you can create an experiment with an existing workspace and how you can configure an AutoML runs and how you can evaluate a trained model on a text data set. So for the initial setup, this is very similar to how you can set up the Azure Machine Learning SDK. We have documentation on that, so I'm not gonna dive deep into this. So essentially, you are going to import a couple of packages from Azure ML Core, and in order for you to use AutoML, you have to import this AutoML config. And this sample notebook is using the latest Azure ML SDK. So in order for you to use AutoML NLP, you have to use the Azure ML SDK that is later than the 1.39 version. So now we are at 1.41. So as part of the setup, you have to create a Azure ML workspace in order for us to connect your training job to your workspace for you to monitoring. So you can connect to a workspace that is already created, and you can provide us with your subscription ID, workspace name, and resource group and location. This is all the initial setup you can do with documentation. And for you to use train an NLP model, you should specify like a compute that you want it to run on. So in this example, we are going to show you how you can use distributed training. So you can specify like how many number of VMs is the maximum VMs that your cluster have, and specify the compute cluster name. So these are all pre-created when you are in the Azure Machine Learning workspace. And I'm not gonna talk deep into how you can create a compute. So this is where you can connect your compute for future use. And I'm also going to show you like how you can connect your data set. So for this example, we are using the archive data set, and this is a data set for the paper's abstract and the naming. So we are using the paper's abstract to predict the specific categories of the paper. And this dataset has already been preprocessed and already been labeled. So after you preprocessing for the labels, we will split the dataset into 3 parts: the train and validation and text dataset. And we will register the train and validation dataset for training purpose. So for a quick reminder, like in order for you to use AutoML, you have to provide us with a training and validation dataset. The validation dataset will be used for evaluating the metrics. So here you can see how you can upload your data to the data store in Azure Machine Learning, and how you can obtaining the training data as a tabular data set to pass in to the AutoML config. So we have created a training and validation data set for the training use. And later, we are also going to create a text data set for you to do inferencing. Now that you have your data set preprocessed, we can start a run with the prepared compute class resource and data set. So on a standard NC6 compute instance with one node, the training would take around 25 minutes, and the evaluation will take around 10 minutes. So for in this example, to make this training faster, we will use a standard NC6 instance with 2 nodes and show you how you can enable distributed training. So you can see in this AutoML config setting, what you need to provide us in order to use distributed training is these 2 lines. So these 2 lines actually configure like what is the maximum concurrent iteration, which is the number of VMs available in your cluster. And this will be pre-configured when you are creating your compute resource. And you need to enable this distributed DNN training, which will enable us to do distributed training for you with the new technologies. And once you have this, you can specify your AutoML config. And this is where you pass what is the specific ML tags you want to do. And for this example, we are doing the multi-label text classification. Tags will look like this. And for multi-class, it will be text classification only. And for NER, it will be text/NER. And here is where you can connect to your compute target, like the training and validation data set, and also the AutoML settings that you just set for distributed training. And for you to use multilingual, you can also pass in a dataset language for us to identify what is the dataset language to run on. So once you have this AutoML config, you can then like submit and start this AutoML runs here, and it will return you with a link to Azure Machine Learning Studio, what is the progress of your training job, and evaluate all the metrics. And the metrics will log with the training run and computed with the validation data set. You can also download your metrics and see it in the notebook. And this is an example of how you can download your metrics and see it. So because of the time limitation, I'm not going to show you the inferencing part, but I will show you a link to all this notebook at the end of the presentation. So now we can back to the presentation. Give me 1 second. So now I want to show a couple of different scenarios that is used by our customers. So we have FinLocker as a customer of AutoML NLP. FinLocker is a fintech company, and they're using AutoML NLP to predict the labels for their transaction memos. So they have 40 million of transaction data about bank account from their financial aggregator, and they want to use AutoML NLP to predict the category and subcategory for the transaction memo that are not labeled. And the customers are using the multi-class classification to classify the main category, and then using a multi-label classification to classify the subcategories for the transaction memo. And they achieve a really high accuracy with this a specific NLP model. And we have a really good feedback from the customers because of the accuracy and also the easy to use. And in the next slide, BRF Personal Foods is also a customer of us. So their IT department often receive a lot of support tickets from their partners, and they want to classify based on the nature of the issue and map the priority of the resolution. And in this case, the customers is actually using multi-class classification and multi-label classification to automate this categorization process. And this really helped them to reduce the time in solving the support ticket. And it can also accurately categorize and prioritize the issue using this machine learning model. And we also received very good feedback from the customers about our multilingual support, since the customers is using different languages, and they're also happy with all the accuracy we have. And we have this compete scenario with our competitors, and we win this customer based on AutoML NLP. So the third customer scenario is from Berry Global. So they are making this plastic container, and their purchasing department wants to create a tool to find the cost-saving opportunities when purchasing the material. And this first step is to classify the type of spending so that they can control and identify the material cost. And so the customers are currently using multi-class classification to classify spend. And we, with AutoML NLP, they can see like a 7 to 10% of jump in accuracy compared to their custom model. So they're really happy about the innovation we are adding and what is the accuracy we can bring to their specific use cases. So these are some quick overview of what are the customer scenarios, and this is really coming to an end of my presentation. And for the next slide, it is some documentation and link to our official docs, which will also include some example notebooks that I just showed. So please feel free to take a picture here and see what are more detail about AutoML NLP, from aka.ms/AutoML NLP. And you can find a clear end-to-end documentation, and also we will link you to how you can do deployment and inferencing with Azure Machine Learning. So that comes to an end of my presentation, and now I'm happy to answer any question you have.